Okay, let's finish up. And you'll notice that the rest of the problems are basically review problems from earlier in the semester. The first one is the midpoint formula. And you can see on the formula page, I give you the midpoint formula and I give you the distance formula. So the midpoint formula we know is you add the x-coordinates and divide by 2. And you add the y-coordinates and divide by 2. It's just the average of the coordinates. So I'm going to say negative 11 plus 1 divided by 2. And then 3 plus negative 5 divided by 2. Notice I'm adding for the midpoint formula. So negative 11 plus 1 is negative 10. Divided by 2 would be negative 5. And 3 plus negative 5 would give me negative 2. Divided by 2 is negative 1. So negative 5, negative 1. What is the distance between 2 points? So the distance formula we're given. I just use the Pythagorean theorem, but if you like that, you can use this one. So that's the distance formula on the first page. So I have to label them. Every ordered pair has an x and a y. This is point 1, and this is point 2. That's what the little subscript tells me. So now I replace them in here when I'm evaluating. So I put parentheses around my numbers so I don't screw it up. So x1 is negative 4 and x2 is 5. And y1 is 6 and y2 is 2. So negative 4 minus 5 would be negative 9 squared. And then 6 minus 2 will be 4 squared. So that will give me the square root of 81 plus 16, which if I use my calculator, 81 plus 16, and then I take the square root of 97, so that will be, this is my square root button is above the x squared, so I'm going to say second shift. That's going to shift the x squared button to the square root, and I'm going to say 97. And I get 9.8488578. So let's write that, 9.848857802. It says rounded 2 decimals. I look at the one that's the next to it. It's greater than 5. So that means I need to change this to be 9.85. Okay, so let's move right along. Graph the piecewise function. And for this one, you will have choices from what this looks like. So what I would be looking for is on a graph. First of all, this is probably the one I'm going to look at for first. That between negative 1 and 4, it's going to just be flat at 6. So this is 6. So I know from negative 1 to 4, it's flat, looks like this. Because it's telling me that y equals 6 when x is anything from negative 1 to 4. So I can graph that, okay? And I know, let's see, let's look at this. This is going to be a negative slope. So without doing anything, a negative slope means going downhill. So anything less than negative 1, any of these values, when it's less than negative 1, it's going to be y is equal to negative 6x. So I know it's going to be going down like this. I could check though. Let's put it negative 1. So what happens at negative 1? So in other words, what is g at negative 1? I'm looking at that point because that's where it changes. So I'm just curious, is it transition or is it somewhere else? So g at negative 1 would be negative 6 times negative 1 would be 6. Aha, so it does make a nice continuous function right here because of negative 1, 6 is right there, so it will continue. And let me just go ahead and see what's happening on this side at 4. So g at 4, if I would look on both sides of it. Now this I know is not actually what's going to happen here, but let's just look and see what happens at the beginning of this one here. So negative 1/2 times 4 plus 4. I'm just looking at what's happening at this end. So negative 1/2 times 4 is negative 2 plus 4 would give me 4 minus 2 would be 2. So g at 4 is 2. It's going to be down here. Okay? And it's also negative, so I know it's going to be going downhill. So without doing any kind of graphing, or, fancy graphing, I can kind of see what it looks like already by just looking at the slope. So this is a negative slope. It's going downhill. And then I checked at this point, it's continuous. So I would have a solid dot here because it's telling me that at the fore end, I want it to be 6. And then this right here is a negative slope. So it's going to be going downhill. And I know that this is for values greater than 4. But at 4, since it's not an equal symbol here, it's not greater than or equal, it's just greater than, I know it's going to be an open circle. And it only could be one of these places because we know if not, it would fail the vertical line test and wouldn't be a function. So this is what the graph looks like. It's a sketch. Okay. And you can use Desmos to help you if you're still struggling on that. So the function, the next one, the function j of x is equal to 4x squared minus 3. What type of function is that? And I gave you that too. I must have been feeling really generous when I made this last week. It's because I don't usually do this, but an even function is f of x is equal to f of negative x, and an odd function is f of negative x is equal to negative f of x. Okay, so we have to check those. So what we're going to do, an easy way to check this is I'm going to first check j at 1, and then I'm going to check j at negative 1. I'm going to see how they compare. That's an easy, quickie way to do this. So 4 times 1 squared minus 3, and I'm going to do 4 times negative 1 squared minus 3. Let's see what that turns out to be. So 4 times 1 is 4, minus 3 is 1. And then 4 times negative 1 squared, that's also 4, because negative 1 squared will be 1. Remember, you always do the exponent first. Negative 1 squared is 1, times 4 is 4, minus 3 is 1. So j at 1 is equal to j at negative 1. And we know that that's the rule, that when j at f of x is equal to f at negative x, we know that is an even function. Okay, if it were not even, right, I would look at it and say, wait, did j at 1 and j at negative 1 give me opposites? In other words, had this been 1 and negative 1, that would have been a signal for an odd function, because I know f of negative x is equal to negative f of x. And if it gave me neither of these, if I got two completely different numbers, then that would tell me that it's neither even nor odd. Okay, 21, find the equation of variation. And we can look at our formula sheet, and I give you a little hint: direct variation, inverse variation, and quadratic formula. Okay, and that's supposed to be over here. I think it's just how it prints on your paper. So this one says it varies directly. I don't know what's going to be in the test, so you need to make sure you understand where all of these are. But varying directly means I'm going to use y is equal to kx. That was given on the page as direct variation. If it said y varies inversely, then I would use the inverse variation. Okay, but this one said directly. So now what I want to do is I want to solve for k, given my two values. So they said that y is 100 and x is 5. So I can solve for k. K is 20. Now, I know what k is, and I have my general form of what my variation is. So all I need to do is replace the k with the number. So y is equal to 20k. I'm sorry, 20x. Okay, we're replacing k with 20. Number 22, find the equation of variation if y varies inversely. Now this one here, we know from the page, this is what inverse variation looks like. So I'm given numbers, 24 for y and 3 for x. I replace them and I solve for k. So I'm going to need to multiply both sides by 3, and I'll get k is equal to 72. Once again, to find the equation of variation, I just replace k with the value I just found. So y is equal to 72 divided by x. Number 23, solve the equation. It's a quadratic, and you may use any method you like. You could try to factor it. You could use quadratic formula. I'm probably going to use quadratic formula because my bet tells me that's not factorable. So you use quadratic formula, you have to be equal to 0. So I subtracted 14 from both sides. I made sure that my square is first, my x term is next, and then my constants. And then I say what a is equal to. A is 18, b is 9, and c is negative 14. The sign to each left is also included of the coefficients. All right, so I have a, b, and c. So I'm going to use my quadratic formula, and I'm going to write it out. And I gave it to you on the first page. So just be familiar with where it's located on yours. So I gave it to you. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So now I'm going to replace each variable with its value, and I told you this is how I do it. When I'm evaluating, I make little parentheses so I don't screw it up. Okay, so b is 9, a is 18, and c is negative 14. So a is 18. So it's negative 9 plus or minus. And when I do this, I always do the discriminant. That's what's underneath the radical. Do that first when I'm using my calculator. You could use on Desmos. You'll see it a little better. But that's 9 times 9 is 81. Okay, and then a negative times a negative is going to give me a plus. 4 times 18 times 14. I get that to be 1,089. And then 2 times 18 is 36. I like to clean it up a little bit like that first. I would probably check it again to make sure. Yep, okay. And now I'm going to do both of these. So I'm going to say, first of all, negative 9 plus the square root of 089. The negative 9 plus square root of 1,089, all divided by 36. So here's how I'm going to do it. I'm going to say negative 9 plus, and then to find the square root, I know I use the, where's my button there? Right here above the x squared. So I'm going to say shift x squared, 1,089. And then I'm going to close the parentheses. That is the numerator, okay? Now, if you're going to do it all in one step, you're going to want to make sure you put a parentheses at the very front and a parentheses at the end. Okay, instead, I'm just going to say enter. That's 24 on the top. And then I'm going to say divided by 36. So I get 0.666667. Or I could simplify this as, we know this is going to be, what, 4 times 6, or 6 times 4. Actually, I can do 12, could I? 12 times 2 and 12 times 3 would give me 2/3. But I also have to remember I have to do both. I have to do when it's a plus and a minus. So let's go over here and do the minus. So negative 9 minus the square root of 1,089. And I'll do it again on my calculator. So I'll say negative 9. Remember the negatives on the bottom row of the calculator. And then minus, and then second, and then the x squared, and then I'll say 1,089. I'll close the parentheses. I hit enter. That gives me negative 42 for the numerator, and then divide by the denominator. And I get negative 1.1666. But you could also, if you wanted to, just go ahead and simplify this. This would be 42 over 36 would be the same thing as writing, let's see if I just did it 6 times 7 and 6 times 6. So it'd be negative 7/6. That's what this value is here. So negative 7 divided by 6 is the same value. So I end up with 2 answers. Okay. And you can give it as a decimal, that's fine. If you want to round that to 2 decimals, that's fine. Just show all your work. What number needs to be added to the expression to complete the square? And they give me an expression. I just want to make sure you understand how to complete a square. Completing the square, you always do the same thing. You add b over 2 squared to complete the square. So in our case, b is the number in front of x, so 24. It's a plus 24. 24 divided by 2 is 12. Squared would be 144. So I would add 144 to that expression, and now I can complete that square. Okay? Number 25. I'll give you a second to read that. Jason jumped off a cliff into the ocean in Acapulco on vacation with some friends. His height as a function of time could be modeled by the function below, where t is in time is in seconds, and h is the height in feet above the ocean. And they give you the model, the equation. Here is the graph, match the parts of the graph. So you can see that this is the graph, Okay, and it's telling you that it's a function of time, so this is always going to be my input value. Whatever you see inside the parentheses, that's always going to be my input. So I know that that is going to be on my x-axis. Okay, and then my output is the entire function h of t. So this is my output, and it tells me that that is the height in feet. So I'm going to go ahead and label that. Okay, so you can see that actually this part of the graph doesn't really apply because time can't be negative, right? You can't have time. And actually, if it went any farther, we know that, well, you could. We're going to just leave it at that. Time can't be negative. So let's look at the pieces here. Label of the y-axis, well, that's going to be the height in feet. The initial height. When we say the word initial, we mean at the start, when time is 0. So when time was 0, if I said h at 0, that's my initial height, would be when time is 0. So negative 16, 0 squared plus 16 times 0 plus 480. I love that one because it goes away, and my height would be 480. And you can see that that point right here, if you weren't given it, is right there. It's when time is 0, so it's going to be on the y-intercept. Now, the time when he lands. So when he lands, we know that means that the height will be 0. So h at t will be 0. That the height will be 0 when he lands, right? So in the water, so we can see that this is when height is 0. It will be the x-axis. And so I have 2 points, either point A or point D. But point A is when time is negative. So we know that's not a valid point. So it's going to be point D. Maximum height. Well, we can clearly see here he's jumping up and then he's falling down. So the maximum he's going to go right here is point C, right there. That's going to be point C. But it's not going to be just point C. It's going to be the y-coordinate of point C. Because you know point C has two pieces. It's going to have the time at the maximum height, and it's going to have the y-coordinate at the maximum height, right? So you're going to want the different pieces. So we want the y-coordinate. We want the height. That's going to be the maximum height there. And then if we want the time, that's going to be point C, but it's going to be the x-coordinate of that vertex. Okay, so it's important to realize that the vertex has 2 pieces. In our case, the vertex is going to be the time at the maximum height, and it's going to be the maximum height. That's going to be our vertex. And in my example, we're calling that point C. 26. What is the end behavior of the polynomial? Okay, so you have to know these. So just like the last one, I don't think I give it to you. Let me just make sure. No, okay, it's not on there. So you have to know these. So we know that if it's an even degree or an odd degree of the 2 things I'm looking at. And I told you I don't really memorize it. I just know that the easiest even degree one to memorize or to know is the basic function. It's an even degree. And the easiest one here would be the cube. And I know what those look like, right? So when it's a positive leading turn, it has a positive coefficient, then I know it's like this one because that's a positive 1 in front of there. And I know both ends of that go up. Okay? And then the same thing here. It's an odd degree. That's an odd exponent. Then I know the left end goes down and the right end goes up. And I know if I put a negative in front of any function, it makes it reflect across the x-axis. So that's my easy way to build that chart really quickly, knowing just x squared and x cubed. So now I look at what I have. I can see my degree. It's the highest exponent. My degree is 9. And that's an odd degree. It's an odd number. Okay? And then I can see that this is a negative number for the coefficient. So it's negative and it's odd. So I'm going to have this one. So my left end is going to point up and my right end is going to point down. Okay. And now my printing's got a little weird here. So let me stop for a second here. So which of the following are x-intercepts of the rational function? And it gives me a rational function. I'm going to write it bigger here to make sure you can see it. Okay, so x squared minus 5x minus 14 all over 8x cubed minus 7, and the function's name is w of x. So which of the following are x-intercepts of the rational function? So how do we find x-intercepts? We know what x-intercepts are always when y is equal to 0. So that would be, this would be equal to 0. And if I multiply through by the denominator on both sides, then I'll only be left with the numerator. So to find the numerator, to find the x-intercepts of a rational function, we set the numerator equal to 0. Okay? So let's go ahead and try that. So x squared minus 5x minus 14 is equal to 0. Well, I can see that I can factor that. I could use a quadratic formula, though, if I wanted to, but I know that I can factor this. So I know that to get a 14 is 7 and a 2, and I know that that would be negative 7 plus 2 would give me the negative 5 in the middle. So x minus 7 is equal to 0, and x plus 2 is equal to 0. So x is equal to 7, and x is equal to negative 2. Okay? So those are my two x-intercepts, and I know to write them as ordered pairs, that means it would be 7, 0, and negative 2, 0. So they're both there. Okay? Now, it may only have one listed. You just choose the ones that are x-intercepts. Which of the following are vertical asymptotes? Now, we know vertical asymptotes for rational functions. We set the denominator equal to 0 after we simplified, because we want to make sure we remove any holes, right, first. So first we're going to simplify. So we are given, for ours, I'm going to make sure, 5x minus 6 over 36x squared minus 1. And I can factor this easily. The numerator, it can't be factored. And then, but there is no greatest common factor, but the denominator I can clearly see is 6x plus 1 and 6x minus 1. So first I check for holes, because if I could simplify, that's a hole, and I don't use that as a vertical asymptote, but I don't have any factors that simplify. So remember, when I simplify, I can only cancel factors, not terms. Terms are added and subtracted. Factors are all multiplied. So if you're tempted to do that, put a parentheses around, set of parentheses around that numerator, because you cannot factor that any farther. In other words, you can only take the whole thing if you're going to cancel. So I can't do any canceling, but I want to set my denominator, that's a minus, equal to 0. So to find the vertical asymptotes, I simplify, just in case there's a hole, but there wasn't, and then I set the denominator equal to 0. So now I'm going to set each factor equal to 0. And when I solve that, I'll get subtracting 1 and divided by 6, x is equal to negative 1, 6, and x is equal to positive 1, 6. And so I have two vertical asymptotes, and I would choose those. If the function g of x is equal to 8x to the fifth minus 41 over 2x to the n minus 7, it has a horizontal asymptote at y is equal to 4. Which of the following is true? Now we know we only have three cases. Okay? When we're comparing the degree of the numerator and the degree of the denominator. So we have three cases. So just to remind you what the three cases are. So the first one is that the degree of the numerator is greater than the degree of the denominator. The second one is the degree of the numerator is less than the degree of the denominator. And the third one is when they're equal. So I'm just going to build this really quickly. So I know, and I told you the mnemonic device that I learned is bigger on top. There is no horizontal asymptote. Okay. Bigger on bottom. Bobo. The horizontal asymptote is y is equal to 0. Now you can't just say 0. You have to say y is equal to 0. And then when they're equal, exponents are the same. Divide the coefficients. So in that case, we're going to say a over b is equal to y. Okay? So those are my three cases. Let's what do we have? We have this one that has a number. So it's not this one, because it says no horizontal asymptote. It's not this one, y is equal to 0. It must be this one, where I have the same degree in the numerator and the denominator. Well, that would make sense, because of 8 divided by 2 is 4. That's where that 4 is coming to. So that must mean that they're the same exponent. So in this case, n will be equal to 5. Number 30. And these print out tiny, but I think they'll still work. So on yours, you can see it. What is the inverse of, and they gave us the function that looks like this. And we know to find the inverse, we change, this was a y, we know f of x is another name for y. So we change the x's with the y's. Okay, so wherever there's a y, I put an x, where there's an x, I put a y. And now I want to solve for y. So to solve for y, I'm going to multiply both sides by y minus 1. And I'll get xy minus x is equal to 3. I just distributed that x to both terms. Okay? And now what I want to do is I want to get the y by itself. So I'm going to add x to both sides. And then I'm going to divide the left by x. And I'll get y is equal to 3 plus x over x. And then my last step is just remember, if you want, that this y really is the inverse of x. So when you go on there looking for it, make sure you find the one that says f of the inverse of x is 3 plus x over x. Not this one. The first one just says f of x. That one would be right. And not this last one, because if you were to break this into two terms, it would be 3 over x plus x over x, which is 1. So it would be 3 over x plus 1, not x. So that's a different form. If you saw that, that would be also correct. So this one or this one. You can graph log of x. I think I've got a typo there. Let me see what that looks like on there. Okay, no, it's just there's no space. It looks like this, really. B of x is equal to log of 8, base 8, of negative x minus 5. So this is the log. Okay, this doesn't have a space very well defined on mine, but this is what yours looks like. Okay, and it says you can graph this using a basic function of just log base 8 of x. Okay, so they're asking you, how do you transform? How do you go from this basic function to here? Okay, and I gave you on the table this time because we've had it several times on different tests, and so I thought let's just give it to you. So here's the table. It's on the front page. I just go right down in order. So let's just start on the top. So what we're trying to do is we're trying to go from log base 8 of x, and we're trying to change it to be this log. Okay, so we're going to see what we have to do. So first of all, is there a horizontal shift? In other words, is something added or subtracting inside with the x? Well, you can see right here, there's nothing added inside the parentheses with the x. So I don't have a horizontal shift left or right. Okay. An example of that would be like log of x plus 8. That would be a horizontal shift left. We don't have that. Okay. Let's look now. So this one right here, what about a vertical stretch or shrink? And that would be a number, a coefficient multiplied outside the basic function. So like 3 log of x on the outside right here. So you can see that we don't have any number here, so I don't have a vertical stretch or shrink. Okay? How about a horizontal shrink or stretch? We know that would be more like this. It would be the coefficient we multiplied inside times that x. And well, we don't have that. We have a negative, but remember the negative we're going to address in a minute. It's not a number, okay? And then the next one here is reflection. The reflection is a negative, and it's important where the negative is if it's in front of the basic function or inside. And you can see ours is inside, so we're going to reflect across the y-axis. Okay, let me cross it out so it doesn't confuse you. All right, so now we have taken care of this so far. We have the log base 8, and we have the minus. We just did that with the reflect across the y-axis. So now we want to keep going. Do we have a vertical shift up or down? And that means we're going to add or subtract outside the basic function, and that's what we have here. So we have a minus 5, so that means we're going to shift down 5 units. And that's addressing this. Now, be careful. I want to point this out too, that if you have log base 4 of x plus 3, okay, equals p of x, to make one up. All right. If it doesn't have parentheses around this, it means this, that this is not part of the x plus 3. If you wanted to have the x plus 3 be together, you would put it in parentheses. So I just want to point out that when you don't have parentheses, that's indicating that this plus 3 is not part of this, okay? And then my last one says, write an equation for a function with zeros at -6, 0, and 2. And this is very similar to the last test we had a problem like this. So first of all, we're going to do that, and then we'll talk about the second part. So to make these zeros, I know that x plus 6, if I set that equal to 0, would give me -6, okay? And then x would give me 0. And then x minus 2 equal to 0 would give me 2. So notice that they're always the opposite signs. So that is my first thing. I can make this, I can call it whatever I want. I can make it be s of x, okay? Now, the next part, it tells you I want to have it bounce back at -6, and I want it to cross the x-axis at 0 and 2. Okay, so when I want to bounce back from the x-axis, I want to have an even multiplicity. When I want to cross the x-axis, I want to have an odd multiplicity. And we know that means that the exponent on the factor has to be even or odd. That's what the multiplicity is. So I want it to bounce at -6. I want to have an even multiplicity at -6. So at this factor, I'm going to make it an even number. It could be 2. It could be 4. It could be 6. It could be 8. It could be 10. It could be 20. It could be 102. It just has to be an even number. Okay? And at 0, 0 and 2, we want to have an odd number. So this could be a 1. It could be a 5. It could be a 7. It could be an 11. It could be any of those odd numbers, but it has to be on the 0 and the 2, an odd multiplicity. And you want to make sure that you have it equal to an output, either y or give yourself a function name. It cannot just be an expression to be an equation. Okay, and I think that does it for the test. So good luck. If you have any questions, let me know.